In our last class, we started with the introduction. We have seen the definition and the components, and then the operations and types of activation functions, and then feed forward network. What do you mean by feed forward network? You have the inputs travel from left to right by going through input layer, hidden layers, and finally to the output layer. And back propagation. Back propagation is uh, again sending the error rate back and using the gradient descent or any other optimization algorithm, learning the new weights or updating the weights uh, in order to improve the accuracy. And this one is confusion matrix. Confusion matrix is the visualization of the performance of a classification algorithm. In this you will have true positive, true negative, false positive, false negative. This confusion matrix typically here you will find here in this slide it is given like true negative here, but then you will get mm, here you just remember that it doesn't matter where you are putting these true negative, false negative, and true positive and false positive. What matters is here what is here and what is here. What are you putting on x-axis? If you have predicted positive, predicted negative, actual positive, actual negative. If suppose you consider fever or consider COVID-19, there are patients. If actually they have the disease and our model has predicted that they have the disease, it is true positive. If actually it is positive and predicted is negative, it is false negative. If actually is negative and predicted is positive, it is false positive. Actually is positive, but falsely it has been predicted as positive. And this is actually is negative, predicted is negative, true negative. This is very important. Please remember this. False positive is known as type 1 error. Keep this in mind that false positive is known as type 1 error. Type 1 error. And false negative is known as type 2 error. This is not an error. This is absolutely right. This one is also right. These two are errors. False positive is an error. False negative is also an error. And false positive is known as type 1 and false negative is known as type 2. And these are quite important things. Extremely important, I must say. Accuracy. How do you calculate an accuracy? Accuracy is calculated by again if I put here predicted plus predicted minus actual plus actual minus true positive. This is false negative. This is false positive and this is true negative. How do you calculate accuracy? This is true positive plus true negative. True positive plus true negative by n. What is n? N is all. TP, Fn, Fp, Tn is equal to n. In means total, when you sum them up, you get. So this you can write in other words, Tp plus Tn by Tp plus Tn plus Fp plus Fn. What is true positive rate? True positive rate is also known as sensitivity, recall or hit rate. Learn, students. Please learn this. This true positive rate is known as sensitivity or recall. What is sensitivity or recall? True positive means this part. True positive by true positive plus false negative. True positive plus false negative. This is known as sensitivity or recall. True negative rate or specificity. Specificity means true negative by true negative plus false positive. This side. This one is specificity. This one is sensitivity. Here Tp by Tp plus Fn. This row, first row. Second row is known as specificity or true negative rate. Tn, true negative plus false positive. This false positive. Positive predicted value is true positive by true positive plus false positive. This column. True positive, false positive. This column is precision. Precision or positive predicted value. Okay. And then negative predicted value is this column. True negative by true negative plus false negative. Uh, this one and this one are important. This one we can omit those one. Others, whatever we discuss, they are important. You have to learn them. These are also not quite relevant for us. F1 score. F1 score is pretty important because F1 score will give uh, you know precision and recall. Precision and recall middle value, you can say in simple words, is F1 score. F1 score will give you balanced estimation. F1 score is 2 TP, 2 into true positive by 2 into true positive plus false positive plus false negative. This equation also you should remember. And remember that F1 gives a balanced estimation of the model. And this is known as AUC curve. Area under ROC. ROC is receiver operating characteristic. Here on x-axis you put false positive rate and here you put true positive rate. And the how true positive rate and false positive rate are related, that is given by this AUC curve. Uh, it's difficult to understand now and I am not going in technical details now because these are the initial classes. Just keep all these things in mind. As we progress, we will study again in detail with examples also. Gradient descent and optimization algorithm. What is the use of gradient descent? It is used to update the weights. W new weights, updated weights is equal to W old weights plus eta means learning rate into this del W. This is actually the gradient with respect to here. the loss with respect to the weights. So you find the derivatives. You find the derivative of loss with respect to weight, and whatever is the value that you obtain, that you multiply with the learning rate, then you add to the old weight to obtain the new weights. Okay, how this learning takes place? If you are here, if you want to reach the lowest value, which is the lowest value? This one is the this point. If you want to reach, if you want to reach this point when you are here, how you can do? You can take steps and move forward. You are here, you move uh, perhaps here, then you move here, then you may move here like this, then here, then you may go in this direction. This you may go in the sense that the system will find out with respect to the derivatives. Uh, with respect to the derivatives of loss and weights, these values are updated, weight values are updated. And eventually you reach here. When you reach here, it means that you have achieved the goal. And then your accuracy will be 100% and your loss will be 0%. If you reached your goal, it means that the predicted value is equal to the actual value and both are matching. When both are identical, if predicted is COVID yes and actual is also COVID yes, then what this implies, there is 100% accuracy for that. If there are 100 such cases, if our model give for 100 cases correct output, then it means that through this gradient descent optimization you have reached the uh, bottom value, which is the desired value. Look at here how it is moving. And no model will give you 100% accuracy. Remember, no model gives you 100% accuracy. It is not possible. Uh, the best model might give you 99% or 99 point something percent accuracy. There is possibility of having wrong classifications. Wrong classifications means false positive and false negative. That those type of classification is possible and it happens in any model. However, your goal is to minimize the loss and maximize the accuracy as much as possible. And this weight updates can be performed stochastic, means one by one. For every data sample you do that. Batch means you group the data samples into smaller batches. uh, no, a batch is entire training set. Mini batch means you group some samples together into batches and then you perform the weight updates. This is updating the weight, that gradient descent. I said no, that one. Back propagation. All right. Back propagation means suppose input is 1 and output is 4, and then if the model generates 2 instead of 4, what we have to do, we have to send the 2 back. 4 minus 2 is 2. We have to send the 2 back based on these weights, 1 into this weight and activation function, and that into this weight and then activation function, and then you get this. If you get 2, 4 minus 2 is equals to 2. This 2 you send back. through back propagation. I am explaining these concepts again and again so that you become very clear, very sure about all this before I start the CNN model. So that is all derivative mathematics and derivations. You go through this this file I will share. You go through if you find if you find it difficult, I will explain you again. This is regression and classification. Two things. This also you should bear this in mind that a regression will give you numeric output. Classification will give you the output based on classes, number of classes. So this is about regression and how it, look at here, it computes the value, numeric value. For instance, prediction of house prices and prediction of price for a newly entered shoe or any price prediction, weather prediction, numeric value, uh, marks prediction, that is regression. Okay students, this file I will share with you. Already all this I have covered, but I am going through. MLP stands for multi-layered perceptron. So ReLU, leaky ReLU, this all we have done. Alright, next we will start with CNN. CNN stands for Convolutional Neural Network. CNN, Convolutional Neural Networks, or convolutions. You can also call them as convolutions, CNNs, or convolutional neural networks. They are similar to neural networks. They too have learnable weights and biases. However, CNN architecture speciality is that it assumes the input to be images, and the architecture is designed in such a manner to operate on images efficiently. Normal neural networks, regular neural networks, they are designed for any kind of input. Sometimes they are not efficient for images. Therefore, CNN architecture was developed exclusively for images. However, these days you apply CNN onto text and other types of sequence data as well. The original idea for having CNN architecture was to operate on images. The significant advantage of CNN over fully connected neural networks is that they reduce the number of parameters. In case of fully connected neural networks, if parameters are 100, In CNN, they may get reduced to 50 or 40. It's like it all depends, but there is a reduction. It's not always 50%, 40%, or uh, we can't clearly state how much reduction. It depends on the number of input values and number of filters and number of uh, the size of the filter and various other parameters. Essentially, the number of parameters are reduced to a greater extent when compared to fully connected or ordered neural network. CNNs are typically applied to image data. What is an image? An image is having different pixel values for RGB if it is color, of only for only grayscale values if it is black and white image, to represent various parts of the image. Uh, and the pixel value will range from 0 to 255. Why 0 to 255? If you use 8 bits, so 2 to the power of 8 is 256, and if you start the value at 0, it will be 0 to 255. 0 to 255 pixel value you can have, and every image will have number of pixel values depending on its size or dimension. What is the dimension of dimension here? Width and height of the image. If we have 1200 by 1920 width and height, this is 1200 and this one is 1920, you will find pixels with some value between 0 and 255. So what will be the total size? Total size will be 1200 into 1920. This multiply by this will give you total number of cells. If each cell will take a singular value, if only uh, if it is a black and white image, it will have uh, one, the color channel will denote 1. If you have a color channel 3, it means that it is a RGB image. Why 3? Because every color is formed by combining various portions of red, green and blue. You combine red, green and blue quantities to get different colors like yellow, pink and purple and various other colors. And you just notice here how much space is occupied by image. We say that image takes more data, more bandwidth, more storage space. Why? Because it requires more pixel values if it is a color, and depending on the size, if you multiply and you multiply 3, that much image will occupy. So this is about images. These are all images. Look at these images. So to operate on these images, CNNs have been designed. Images are arranged in layers as matrices with 3 dimensions. What are the 3 dimensions? Width, height and depth. What is the depth? The depth is this nothing but a channel. If you have 3 channels, it is color image. If you have 1 channel, it is black and white image. Width of the image, it denotes the number of columns in pixels. How many columns you have. Width. Height will denote how many rows you have. And depth will denote how many colors are there in the image. Okay, this width, height. Look at here. It is divided. Every pixel will have a value. Here you see 1920, 1200. This is width, this is height. 1200 rows and 1920 columns. Students, please focus here. This is quite important. This one is red channel, this one is green channel, and this one is blue channel. So you have 3 channels, means it is a color image, RGB. Here you will have some value, here you will have some value, and here some other value. These 3 will denote the value for this pixel. Then for this pixel, you have to take this one, and this one. This is 1, pixel 1, 1, 1. Here 1. This is 2, pixel 2, 2, 2. Here this pixel 2. Because it is a color image, you can see it is a color image. It has 3 channels, red, green, blue. Red has value 68, green has a value 85, and blue has a value 33. These 3 together combine to find this pixel 1 value. Like that you have values for every pixel. If it is a black and white image, look at this is black and white image. And the number of channel only 1. 0, 0 means 0 denote black. And 255 denotes white. If here 0 means this is black, this is 0, black. So wherever you find 0, it is black. It denotes the color black. And here you will have 255, 255. And look at here, this is gray shade, not white and not black. This might be 150. So you will have here somewhere 150 and here 255 for this black and white image. Okay, images concept is clear. Any doubt you can ask. If clear, we'll go ahead. Convolutional neural network architecture is arranged as a sequence of layers, and you have different kinds of layers, which are convolutional layer, pooling layer, flattening layer, fully connected layer. Convolutional layer, students, again I will give you the differentiation so that you don't get confused. If you consider a regular neural network, you will have the nodes, and this node is connected to all the nodes in the subsequent layer. This node is connected to all the nodes in the subsequent layer, and likewise all are connected to all. This is also known as fully connected neural network. This is known as fully connected neural network. In this you have only input layer, output layer, and hidden layers in this type of network. In convolutional neural network, you have convolutional layers, pooling layers, flattening layer, fully connected layer. Alright, look at here. There is a difference, and obviously here you have input layer. Sometimes in this input layer is combined with the first convolutional layer, or you can have a separate input layer. Input layer is given, receives the input and forwards to convolutional layer. Convolutional layer performs some operation and forwards the data to pooling layer. Pooling layer will do some operation and forwards the data to Here one more point you have to remember. This convolutional layer and pooling layer may occur in any number, and it is not necessary to have one convolutional and one pooling. You can have two convolutional layers and one pooling layer. This are all design issues, design concerns. Whenever you are designing a new convolutional network, you have to uh, come up with some architecture that is most efficient for your problem. Basically, the convolutional neural network has convolutional layer, pooling layer, flattening layer, fully connected layer. But their arrangement varies and their count also varies. Like you have here hidden layers, here I have two hidden layers. You can have 5 also. You can have 6 as well. So here it depends on the problem, the architecture and the accuracy and various hyperparameters. Here same case. Similarly, you can have any number of convolutional layers, any number of pooling layers, but flattening layer is only one. This is only one. Fully connected layer also you can have any number, 2, 3, as you like depending on the uh, data set. Convolutional layer, what does it do? This is the most important layer in convolutional neural networks. Convolutional neural networks will identify the features through filters. This layer has filters, and these filters will output feature maps or activation maps. And this CL means convolutional layer. This CL also uses the activation function, mostly the ReLU, rectifier linear unit. ReLU stands for rectifier linear unit. Pooling layer receives the input from convolutional layer, and pooling layer decreases the number of neurons, means the size, number of parameters. The size is decreased uh, in pooling layer. In flattening layer, the matrix is converted into a vector. This 1, 2, 3, 4. This is a matrix, 2 by 2 matrix. This 2 by 2 matrix will become 1, 2, 3, 4. A vector, 4 by 1. Vector will have only one single column. So this is flattening layer. Fully connected layer is similar to this one. Same as it is. Every node is connected to every other node. So our normal neural networks are here as fully connected layer. Before them you will find flattening layer. Prior to flattening layer you find pooling layer. Prior to pooling layer you find convolutional layer. Prior to that you find input layer. Apparently CNNs are extensions to fully connected neural networks and are optimized to work with images. This point has already been discussed, but let us discuss again. This is a data set of dogs. This is data set of lions. If the data set contains 100 images of dogs, look at here at different angles and different parts of the dogs, uh, left side, right side, face, and tongue in, out, all these different images of dogs. If they are in 100 number, they are divided into training set. 70% means 70 images. Validation set 20% means 20 images, and test 10% means 10 images. So totally you get 100 images. You train the model using 70% of the images, 70 images chosen randomly, and the other 20 images chosen randomly will be used for validating. Validating means uh, verifying the results of the model. If required, you can adjust the hyperparameter. You can tune the hyperparameters. And finally, last 10 images you use which have never been seen by the model, which are absolutely new to the model, are given to model for testing whether model is able to correctly predict or classify, in fact, that this image is a dog image. You see, these are not repeated. If you have repeated images, then how will you know whether the model has learned the characteristics and features of the images properly? You will not know. Okay, the pre-processing which is done uh, before feeding the input to the CNN are these things. You can rescale the image. Rescale image means that you have to divide the pixel value by 255. Why 255? Because the maximum value every pixel can hold is 255. So essentially, if you divide it by 255, you get all the values in the range between 0 and 1. Okay. Uh, Actually, pixel value you saw earlier, the 68, 129, 55. These are the pixel values. In order to rescale and in order to have a standard values for the pixels, these are every pixel value is divided by 255. 68 by 255, 128 by 255. If it is pixel value is 0, 0 divided by 255 will be 0, 0. If it is 255, 255 divided by 255 is equals to 1. So all the values come in between 0 and 1. That is known as rescaling. Feature wise centering, you can have the dataset mean value equal to 0. Then you will get, you are like centering. The data is centered like this. And you can do it for sample wise centering. Sample mean to 0. Feature wise STD normalization, divide the dataset by its standard deviation. If you divide the dataset by you can compute its standard deviation and divide the data by it, then it is like you are normalizing based on the feature. Sample wise, you divide each sample by its standard deviation. Here you divide the dataset, only training dataset, by standard deviation. Here you divide each sample, training, testing and everything. Okay, so rescaling is the most used pre-processing procedure, which is nothing but dividing the pixel values by 255. In order to apply convolution, you have to consider some parameters. What are they? Kernel. Kernel is also known as filter. If any one of you has studied image processing, you will know that there are some kernels, Sobel kernel, Privet kernel, like this kernels will be there. 111 000 000. This is one type of kernel. This is also known as filter. So a convolutional layer has a kernel or a filter, and every cell in this filter will have a weight. That weight you apply uh, onto the input image pixel values, and depending on these weights, these filters will find the features. What are the features? If you consider the image of a dog, like hmm, this. So if you consider this image, you can see that there are some circles like eyes, okay, and there are some colors for these eyes. There are some edges. There are some other shapes like triangles or polygons, or you can see oval shape. Different shapes you will find in an image. So those shapes and different colors also you will find in an image. Those colors and those shapes are known as features. They are like curves, edges, colors, and then this kernel is moved over the whole image from left to right and top to bottom by applying the convolution product. The operation that it applies is a convolution product, means this into that. Uh, I will show you how it works, but theoretically you try to understand that this kernel, this is an image, there is a large image, and this is a filter or a kernel, and then you slide it over this image from left to right and top to bottom. While sliding it, you perform an operation. Which operation? Convolution operation, which is here in this context means uh, dot multiplication. Dot multiplication. And the convolution product is an element wise multiplication, and the output is known as filtered image. And these weights here, whatever values are there in this kernel or filter, these are trainable parameters or known as weights. Stride defines the step size. Do you want to move this filter one after the other, or you want to jump every two column you want to move, shift it? How you want to traverse the filter over the image? That is a parameter given by stride. Default is 1, so it just moves 1 1 1 1 1 like this. Padding is also a parameter. This padding will determine whether the output uh, of the convolution operation is identical in size to the original input, or is it a reduced version of the original input. Generally, if there is no padding, then it will be a reduced version. If you add a padding, then the output feature map is exactly the same size as the image. So the resultant and everything, these all are matrices. You have filter matrix, you have image is also a matrix of pixel values, as shown uh, earlier. So that resultant is known as activation map or feature map. Mathematically, you represent an image as this: width, and this is input in, height, and depth, means whether it is color or black and white. And there are 4 hyperparameters. Hyperparameters are those parameters that needs to be set by user. There are 2 types of parameters in deep learning: parameters and hyperparameters. Parameters are learnable or trainable. This parameter values will be learned by the model. Hyperparameter values will be initialized by the user. User will specify the values. In convolutional layer, there are 4 hyperparameters: number of filters, how many filters you want to have. You can have many filters. You can have 10 filters, 16 filters, 20 filters, 30 filters. Size of the filter, you can have 3 by 3 filter, 5 by 5 filter. Stride means how you are moving the filter over the image, 1 step at a time, 2 steps at a time, or how many steps at a time. Amount of padding, if you apply padding, the resultant size is same as this input size. Otherwise, resultant size is reduced and produces an output of size. This is the output. W out, width, height, depth. What is W out? Is equal to W in minus n plus 1 plus 2 into P by S. Okay. Consider 28 by 28 image. Here. This is 28, 28 and 1. Okay. And consider this to be 3, 3. This to be 1. This to be 8. This to be padding 0. And these are the values. Can anyone who are there in the class, okay, can anyone tell me uh, this W out for this? W in is 28. Minus n. N is 3. Plus 1. Plus 2. Into P. 0. So this will be equal to, this is 0. This is 28 minus 4. 24. Means output to width is 24. This is 28 minus m is 3 plus 1 plus 2 into 0. Oh, divide by s. S is 1. So it is divide by 1 is 24. This is also divide by 1. So this is equal to 24. Students, is it making sense? So size is reduced. If you have padding 0, size will be reduced. If padding is 1, if you put 1 here and see what will be the value. This will be 2, 24, 28, 3, 25, plus 1. 26 plus 2, 28. If you put 1 here, oh sorry, this is 20, 28 minus 3 is 25 plus 1 is 26, not 24, sorry. This is 26. Students, you should tell me no, please. This is 24 is the width, input image width. Minus 3 is the filter size. So 28 minus 20, 28 minus 3 is equal to 25 plus 1 is equal to 26. If padding is 0, size is reduced. Instead of 28, now output is 26 width. If padding is 1, output is 28 only. D out dimension is equal to depth. Depth is equal to number of filters. Here number of filters are 8. So you will have 8 as the depth value. These are the feature maps. For this image, after applying convolution operation, you get this feature map. For this image, you get this feature map. This is a grayscale image. Okay, they are uh, uh, here. It is being solved. Those equations are being worked on. If you take width, height, depth 5 by 5 by 1 and filter 2 by 2, then what will be the feature map size? It will be 4 by 4 by 1. And how the, okay, look at here. This is feature map. You place it on top of the image. Then you compute the convolution value, which is nothing but multiplication. And then you put the value here. And then you move this. Here you got this is 0 into 1, 0. 1 into 1 is 1. 0 into 0 is 0. If you don't understand, you can uh, interrupt me and ask. This all are extremely important for you to understand. This is our feature filter or kernel. This is our image. This is the feature map. How are you getting this value for feature map? You perform multiplication operation. These image values are 0 1 0 1 and filter values are 1 1 0 1. Then you get 1. Here you get 1 into 1 is 1. This 0, this 1, this one is this one, this one is this one, and this one, that this one is this one, and this 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 one. So there are two ones, then there are two ones here, so you get 2. So you are getting 2 as the value here. Okay, look at here. When stride is 1, It takes just one step. It moves from 0th column to first column. Initially it was on 0 and 1. Now it is on 1 and 2. Means there is a step of 1. This is moving one step ahead. If you give stride value as 2, you will find this filter to be over 2 and 3, not 0 and 1, because it takes 2 steps, not 1 step. And here, because there is this, here you have 1, here you have 1. Here the 0 0 means this 0 0, and here 0 means 0, so you get only 1 as the value. Like this process continues. Look at here. Every pixel value is determined by multiplying filter value with the image pixel value. And now you see you got the entire feature map, and here you have 1 2 3 4 5. This is 5. So 1 2 3 4 5. This is 5, and this is 5 by 5, and because it is black and white, 1. If you count here, you find this 4 and 4, so you will get 4 by 4 by 1, because there was no padding. If you use padding, here you add one more, you know, row and column. Not row and, not one more row and column. It is like, yeah, one row you added for all the columns. Then what happens? This filter will be here, like this. Then you get the size same as this size. If you perform padding, these are, look at here, 5 by 5. Here you are getting 4 by 4. Weights are shared. How weights are shared? When the filter is like this, this is computed from this one and this one, this one and this one, this, this one, this one, this one, this one. And here you have weights for this and this and this and this, 4 weights. Then you get this value. So weights are shared, and these are known as trainable parameters. This filter values or kernel values are the trainable parameters. Initially you may give here randomly 1 1 0 1. These are random values you have initialized. After you obtain the result through back propagation, these values are updated. And look at this, when it is a black and white image, there is a single feature map. For RGB image, you get 3 feature maps, because every feature map, uh, when combined with the other 2 feature map, means red combined with green and blue, blue combined with red and green, gives the pixel value. This is, here in this case you have only one filter. Here you have 2 filters. When you have 2 filters, if you observe here, 2 filters, you get here 2 feature maps. Here, look at here, this is known as zero padding. When you pad, then you get the result size same as input size. Look at here how it is performing. I'll share this with you. In the classroom I will post, you can go through. Okay, like this, step by step with padding. How it is done with padding. And activation. Okay, activation, we will look at tomorrow. Any doubts in today's class? Okay, then see you tomorrow. Yes, Rachana, do you have any doubt?
Yes, ma'am. For each pixel, we have the values from 0 to 225. No, ma'am.
Yes, 255.
It's ma'am 255. For each value, we have color, ma'am.
Um, if it is color means that pixel will have three components, not just single value. It will have three
Ah,
values.
okay, ma'am.
It will have three values. Suppose yellow color. Uh, if you want a yellow color, then what you have to have, some portion of red, maybe 142, plus green, maybe 70, plus blue, maybe 10. When you combine all these pixel values, you get this result. So it is not a single pixel value. When it is color, you will have three pixel values for color. Yes,
Okay, ma'am.
Rachna,
Okay, ma'am.
got it?
Yes, ma'am.
Okay,
Ma'am, the value will be fixed for each color, or they will be differ.
it differs. It differs. It is not fixed. Means when you combine different values, you generate
One color.
thousands and thousands of colors. Look
Yes,
at this, how many combinations you get. 255 to 255 to 255 combinations of colors you will get. I think in paintbrush you have that, no?
uh,
I'll show you. It is color, edit color. Here you see red, green, blue. Are you able to see?
yes, ma'am.
Red, green, blue. If I give green as some value, and blue as some other value, you get, look at here, this is the generated color. When red is 0, green is 10 and blue is 89, this is the generated color. If I add some portion of red, 120, look at here, this color has changed.
Yes, ma'am.
So you have three different values. Together, when you combine, you get color. And this one, it depends on what proportion of each color you are mixing. And then you get that color. So that value is, that color, whatever color gets for these three different values is fixed. But then it depends on the image. In image, what are the colors? If suppose you have a cat image, if cat is a brown cat, then pixel value will have brown color. If cat is white cat, it will have pixel values more towards 255. If it is a combination, you will have combination of pixel values. I will give you an demonstration of this in tomorrow's class. Practically also I will show you.
Yes, ma'am.
uh, okay, theoretically is it clear?
Yes, ma'am.
Okay, Yasin, is it clear? Okay, okay then. Bye. See you tomorrow.